Today we'll be looking at sample space and tree diagrams, and we're going to be focusing on experiments where there's more than one step to it. So when experiments have more than one step, we call them multi-stage experiments. So it might be that we've done two things in a row and we're looking at those combinations. Now there's a couple of ways that we represent this. One of them is to use an array or a table. So this is typically for two-stage experiments where you can use the two dimensions in order to show the crossovers of all of your outcomes. Once you've got more than two stages, then we'd be looking at using a tree diagram. So a tree diagram can be used for three or more, or you could even use a tree diagram for a two-step experiment as well if you wanted to. And it's a really nice way of showing all the different possible sample spaces. So let's have a look at this first example. Two dice are tossed and the sum is calculated. First part, organize the sample space into a table. Second part, find the probability of these different things. So when we're looking for these probabilities, once we've got our table, that's actually going to help us to solve these problems. So because I've got two dice, it makes sense to have the two dimensions. So I've got one of the die along the top, and then the second die is along the side there. Now in the question, I've said that we're calculating the sum. So we're going to add these numbers together. So our first one was a double 1, so that's going to be a 2, and then a 1 and a 2 is going to be 3, 4, 5, 6, 7. And then 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9. And we just want to fill in this table here with these numbers. 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, and 7, 8, 9, 10, 11, 12. So what we've done here is we've written out all of the possible outcomes. There's 36 of them because you've got 6 numbers on one die and 6 on the other one. And then what we want to now do is look at what favorable outcomes we have for each of these questions. So the first one, find the probability the pair is a double. So double means that you've got a double 1, double 2, double 3, or so on. It's going to be this one, this one, this one, this one, this one, or this one. So the notation we're going to use is P bracket, and then we'll write the description inside. So double, so P double. We have 6 different values out of 36, and then we can simplify that. That's 1 out of 6. For part 2, we want the probability, the sum is 6. So we need to go through our diagram. Where are our 6s? 1, 2, 3, 4, 5 of them. So that's going to be 5 out of 36. Part 3, the sum is at most 4. So the maximum value we want is 4. At most 4. Now, remember we said before, when we look at this word at most, sometimes we want to determine what the complementary event is, because sometimes that's easier to calculate. So if I want at most 4, the opposite of being at a minimum of 4 is being less than 4. So we could write this as 1 minus the probability it's less than 4. And that's actually not too hard to calculate, because if you look at your diagram, if you want less than 4, then it's that one, and that one. So then you've got 3 values. So that's 1 minus 3 of 36. That's going to be 33 of 36. All that simplifies to give 11 out of 12. So sometimes that's just a little bit easier. Otherwise, you could have just added up all the other ones. So we could have gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, if you add them all up, it should be 33. Okay, so that's another way you could have calculated it. Right, let me just color code these. All right, we're looking at part 4 now. So part 4, we want the probability that the sum is not 7. Okay, so again, there's the word not. So complement will probably make this calculation easier. So probability not 7 is 1 minus the probability it is 7. Okay, it's a lot easier to count up the ones that are 7 than not 7. So we're going to pick out all our 7s. They're along here. So there's 6 of them. So what we want is 1 minus 6 out of 36. Now 6 out of 36 is 1 out of 6. That's going to be 5 out of 6. The last question we have is that it isn't a double 6. So again, is not, so probability not double 6 is going to be 1 minus the probability of actually getting a double 6. The probability of getting a double 6 is just that one option. There's only one way of doing it. So that's going to be 1 minus 1 out of 36. Well, that's 35 out of 36. So that's how we can use a table to represent our results. Now, it doesn't have to always be two exactly the same experiments. So it doesn't have to be 2 dice. It could be a dice with a coin. Okay, so then you'll have slightly different outcomes on each of your dimensions of your table. So you just need to make sure you're reading it carefully. The other thing that we're going to look at is tree diagrams. So we've got a family of 3 children. We want to find the probability of each of these following. Now, I haven't given you any guidance, so you can choose to do this in whichever way you want. Because we have 3 children, it means that we've got 3 steps in this experiment, which means a tree diagram is probably the most appropriate to use. So what we're going to look at is drawing our tree diagram. The first branches is going to show the possible outcomes for the first child, the second one will be the second child, and then the third lot of branches will be for the third child. So we're going to have 2 branches. So the first child can either be a boy or a girl. Once we got our boy or a girl, the next child can also be either a boy or a girl. When we get to our third child, that's going to be the same again. Okay, so boys and girls are equally likely, or we always say that they are. There we go. And so because we know that they're equally likely, this tree diagram is just going to look like this. If the outcomes aren't equally likely, what we will also do is we'll put probabilities on those branches. And I think that's coming up a little bit later in this chapter. What we might also want to do is actually write out our outcomes. And basically what we're going to do is start from the top and then go along the branches and then just write out what each of those possible values are. So we could have boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, and boy, girl, boy, girl, 2 girls and a boy, or 3 girls. Okay. So all I did there was I just worked out along each of those branches systematically, just working my way down, and then I've just written them out here. So it's nice to have a summary of this, and then you can look at the list in order to work out the answers. So for the first question, what is the probability that the eldest is a girl? So you want to look at those. The first one needs to be a girl, and you can see in each of those 4, you've got the first child is a girl. So then part A, probability eldest is a girl. It's going to be 4 out of 8, which is a half. Part B, we want to have 2 girls and 1 boy, and that's in any order, so it doesn't say anything, so we just want 2 girls and 1 boy. So when we go through this list, 2 girls and a boy, 2 girls and a boy, and 2 girls and a boy. So there's 3 outcomes. out of a total possible 8. Let me just move that down here. Next question. We want the probability there is at least one girl. Okay, so again, the word at least. Okay, sometimes it's easier to work out the opposite. So the probability at least one girl is going to be 1 minus the probability of no girls. Okay, so that's what your opposite will look like. So if it's no boys, no girls, then that means they're all boys. So there's only one way of getting that. So it's 1 minus 1 out of 8, which is 7 over 8. With our last one, we want more boys than girls. So D, if we want more boys than girls, it's probably easiest just to read through the lists and work out which ones they are. So more boys than girls, definitely that one's more boys than girls. 2 boys and a girl is also, that one's also correct. Boy, girl, girl, there's more girls than boys in that family, so we don't want that one. But we've got 2 boys here again. So basically the majority is boys, so then you need 2 or 3 of them. And so you've got 4 outcomes. So probability more B than G will be 4 out of 8, which is again a half. So if you want to have a go at some of these questions, you will need to draw your own diagrams. Part of it will also be with your tree diagrams, knowing what your branches need to be in each of your stages.